Okay. We're going to be talking about what we call sex-linked inheritance. So you can title these notes sex-linked inheritance. What does it mean to be linked to something?
Connected.
To be connected. Attached. You're hooked on it, right? You're linked to it. Hooked up to it. So these are traits that are on the sex chromosomes. So we said we had how many pairs of chromosomes?
46. 23. 23.
All right, we have 23 pairs. 22 of those are what we call autosomal, which really just means they're not sex chromosomes. So 22 of those pairs for a total of how many? 44, right? 44 of our chromosomes are what we call autosomal. And then we have one pair of sex chromosomes. So if you hear somebody say that something is an autosomal trait, that means it is on a chromosome that is not a sex chromosome. Now, does anybody know what letters do we use to represent the sex chromosomes? X and Y. Okay, so our two sex chromosomes, if you're a female, you have two X chromosomes. And this is the symbol for female, like that. We'll probably use that a lot. If you're a male, you have an X and a what?
Y.
X and a Y. I'm proud to be the home of a Y chromosome. I saw that on TV. Don't repeat it. And that's the symbol for male. It's kind of a circle with an arrow.
I like female better. It looks like a person.
Yeah. That's kind of like a person.
person.
So, two X chromosomes makes you female. X and a Y makes you male. Now, if we want to do a Punnett square with this, when we do sex-linked Punnett squares, we're going to be using X's and Y's. And we're always going to have two X's, and we're always going to have an X and a Y. Why? Because it's male and female, and that's the only way sexual reproduction works.
But doesn't that mean that one have to be a male and a female?
We're not going to get into that today. Traditionally, we put the male genotype on the top of the Punnett square and the female on the side. It's not wrong if you don't do it that way. That's just the way convention. I don't care how you do it. I just thought I would mention it. Yeah.
Why? Okay, this is really stupid, but why can't you have two Y chromosomes? I mean, like, why would, like...
Because there are genes on this X chromosome that everybody needs. Okay. So if you had two Ys, that embryo would not live. Okay. And you're going to see in a second why it's really not possible to get two Ys. Because if we do this, remember, we say that each one of these represents a gamete. So these two would represent what type of gamete? Male gametes, which are sperm. And these would represent eggs. One thing you need to notice is that every guy in this room got their Y chromosome from who? From their dad. And since you're going to get one from dad, that means you got your X chromosome from your mom. So if we filled this Punnett square out, you'll notice that you got 50-50 chance of being a guy or a girl. Literally, yeah. And also the guys got their Ys from dad, and they got their X's from mom. And this is going to be important when we look at sex-linked traits. Now, girls, they get one X from mom and one X from dad. So let's just jump right in. We're going to do an example problem of a sex-linked trait. We're going to do color blindness. Does anybody know anybody that's colorblind?
I do.
Or do you know that's colorblind?
Hold on, I gotta think of the person's name because I know somebody that is.
My cousin, my mom's boss is colorblind, and he always has to ask her if his time matches.
All right, and obviously he's a male, right? Yeah. All right. Do anybody else know somebody that's
My
colorblind?
cousin was.
Guy or girl?
Yeah.
Anybody else know somebody that's colorblind? He's a guy? Guy? Your dad? All right, what we're going to find out is you can be colorblind to be a female, but you're more likely to be a male. And here's going to be why. So let's look at color blindness. Color blindness is what we call an X-linked. What do I mean by X-linked? What chromosome is it on?
No,
The
girl.
X one.
It's on the X chromosome. Now, guys have an X chromosome as well. It's called an X-linked recessive. So this tells you two things. Number one, it tells you that it's on the X chromosome. The gene is on the X chromosome. And it tells you it's what type of a trait.
Recessive.
It's recessive. So in order to have it, you got to have how many alleles for it? You got to have two. Because if you just have one, there's something to cover that up. What's going to cover it up? The dominant allele. So the way we can draw this is I'm going to start with the females. So whenever we write a female genotype, we have to write two X's. And we're going to use the letter C to represent color blindness. So if a female is totally normal, she is going to have two capital C's. That means she has two dominant genes. And we write a superscript. What's a subscript?
Under, like at the bottom.
Right, a subscript is when it's like below the letter. Superscript is when it's above. So we're going to use superscripts when we do
So the
sex link.
C stands for colorblind.
Colorblind. Well, yeah, but these are, I hate using C's because it's hard to tell if it's capital or lowercase, but these are both capital, okay? So if she has two capital letters there, then that means she is totally normal. She does not have a colorblind gene. She's not colorblind, okay? Now let's do another female genotype. What's another way we could do her genotype?
Capital C both.
We could do heterozygous. We could have one dominant and one recessive. Now, colorblindness is recessive, so will she be colorblind?
No.
All right, so we say she's not colorblind, but we have a special name for her. We call her a carrier. Why do you think we call her a carrier? Because she's carrying one of those genes, and even though she doesn't have the disorder, the trait, she could pass that gene down. So she's what we call a carrier. And what's the third type of female we could have?
Both lowercase.
Both, we could have homozygous recessive, and this would be a colorblind female. Does anybody know a girl that's colorblind?
Yes, the one I'm talking about.
The one you're
cannot
talking
remember her name, but
Okay.
she's colorblind.
But everybody else that knows somebody's colorblind is a guy, right?
Right.
Right. Well, we're about to see why. Now, here's the problem. This trait is a what type of recessive trait?
X-linked.
X-linked. So it means it's on what chromosome?
The female.
X chromosome. So is it going to be on the Y chromosome?
No.
No. So let's do a male genotype.
So would all a guy have to have is a lowercase c?
In order for a guy to be colorblind, he only has to have one recessive. If this is the guy's genotype, he's going to be normal. Because look, he has a dominant gene, right? You don't put anything on the Y. Because this gene does not exist on the Y chromosome at all. It's not there.
Okay.
So you just, it's almost like you just pretend. Now there are Y-linked genes. There are genes on the Y chromosome, but this is not one. So it's almost like we pretend like
It doesn't exist.
it doesn't exist. If a gene is on a Y chromosome, can a girl have that trait?
No.
No. Now, the only other genotype for a guy is one recessive, and this guy's going to be colorblind. Now, normally you have to have two recessive genes to have a recessive trait, right? But there's only one X here. That's right. So because there's only one X,
So there's not.
he's only got to have one. Right. There's no dominant to cover it up. So this is why guys are more likely to be colorblind than girls, because guys only have to have one colorblind gene, and girls have to have two.
Okay.
So let's do a Punnett square with this. Just over here to the side. If we take a normal male, and let's say they have kids with what we call a carrier female. So what do I mean by carrier?
She's got the gene, but she doesn't have it.
She's heterozygous. She's got one gene, but she's not colorblind.
Did you do that wrong? Like, I just
Yeah, it doesn't matter. Yeah, I made my rule and then I broke it. So if we fill this Punnett square out, let's see what we wind up with. Now we're going to do our ratios a little bit different. Our probabilities are going to be a little bit different on this.
Is that, I know you probably already said it, but on the male X, is that a big C or a little C?
It's a capital. He's normal, so it's a capital. So it's dominant, and then she's heterozygous. She's a carrier. When we do our genotypic and phenotypic ratios, we need to distinguish between male and female. So what we need to do is we need to say, we can't just say how many are colorblind and how many are not. We need to say how many colorblind girls are there, how many normal girls. So let's say how many normal females. What's our odds of getting a normal female?
100%.
Huh?
Oh,
well, okay, I see what you're saying.
Yeah.
Yeah, you're a step ahead. Well, it's 50%, right? There's a 50% likelihood that we will get a female that is normal. Now, if I rephrase the question and said, if we have a girl, what are the odds that she'll be normal? It'd be 100%.
How would it be 50%?
How would it be 100?
Because all right, there's 2 out of 4 that are normal females. So that would be 50%,
I
right?
thought a normal female had to have 2 weeks.
Well, what I mean by normal is not colorblind. Sorry. Yeah, one of those is a carrier trait. This one is a carrier, but her vision is going to be normal. She's not colorblind. Because in order to be colorblind, she's got to have 2 recessive genes, right? Because it's recessive. Okay. And then of having a normal male, what's the odds?
You was just talking about 100%. If like you rephrase the question, how do you get 100?
Okay, here's what I meant by that. If I were to ask you, what are the odds of getting a normal female? You would say it's 2 out of 4, right? But if I rephrase the question and I were to say, okay, we have a girl. So if we have a girl, doesn't that mean I ignore these guys?
Yeah.
And I say, what are the odds of this girl being normal? It's 2 out of 2, which is 100%. That's where I think some of these questions might, you have to pay attention to the way the question is phrased. Okay? For example, the odds of getting a colorblind male is going to be what? 1 out of 4, which is 25%. But if let's say that this was my wife and I having a kid, and we know we've got a boy, what are the odds of that boy being colorblind? It's 50%. Because we know it's a boy, so we're going to ignore the girls, right? And in that case, it's going to be 1 out of 2, which is 50%. So you have to pay attention to the way the question is phrased.
So how much more likely is a boy to be able to grow?
Well, it depends on the parents. The main thing is, like, in this circumstance, okay, all your girls are going to be normal, but some of your guys are going to be colorblind. If you have a female that is colorblind,
Then it's 20%.
well, if we just think about our guys always get their X from who?
Mom.
From mom. So all of if you are a girl and you're colorblind, if you have a boy, they're going to be colorblind.
Really?
Because you have 2 colorblind X's, and your son is going to get his X chromosome from you, and all you have to give is an X chromosome that has a colorblind gene on it.
But the girls.
But the girls would have, if the dad's normal, then the girls are all going to be carriers, right?
Right.
Because they're going to get that dominant gene from dad, and they're recessive. They'll all be carriers, but they'll all be normal. So if a girl is colorblind and she marries a guy who is not colorblind, all their sons will be colorblind, and all of their daughters will be carriers, but they'll have normal vision.
Right.
Right? Isn't genetics cool?
So if a dad is colorblind, the girl has